The outcrops to be visited are located on the south coast of Trinidad at the western side of Quinam Bay. The outcrops are of Cruse Formation of Pliocene age. The various formations have been defined using assemblages of benthonic foraminifera. These are important as all sands, silts, and clays of the forest and Cruse Formation are almost identical in grain size and compositions. Paleontology is thus the only tool to separate them. The major structural elements in the area are the northeast to southwest trending and plunging southern anticline and the Los Babos Fault to the north. We are looking at a close-up of the Kugler surface geology map. Mud flows have been mapped along the road. At the beach facility, Lengua Formation is supposed to outcrop. The lines of dots on the map represent sand beds. The structural cross-section attempts to illustrate the south-dipping rocks on the coast and the source of some of the exotic clasts on the coastline. A small mud vent along the Quinam Road. It's a water-filled pool from which small gas bubbles have been escaping for a long time. We will now review some of the published research that will give us some context to the outcrops that we will be visiting. In 1958, Barr, Waite, and Wilson published a mode of oil occurrence in the Miocene of Trinidad, British West Indies. To date, it is one of the most comprehensive reviews of the Cruse, Forest, and Monlafo formations. This map shows that the Cruse has predominantly southwest to northeast sand trends. Payne et al. In 2007 discussed the changes to the surface geology in the Quinam and Bon Diablo areas after reviewing the results of 4 exploration wells. They indicated the wells spud in forest formation and not Cruse or lower Cruse, but this topic will be discussed another day. Wilson and Vincent in 2014 and 2015 indicated sediments deposited at these outcrops were done at lower bathyal to abyssal type depths. Chen et al. In 2016 indicated shelf edge collapse was an important process. This is a diagram illustrating the 4 main deltaic cycles within the southern and Columbus Basin and its lateral changes through time. Here we have a sketch map of the Quinam Bay area illustrating the orientation and arrangement of the sand and claystone beds. Key to note is the extensive slumping with large folds. Drone photos highlight the slump fold and parallel bedded claystones. At that time in 1965, the slump beds were interpreted to be mud flows associated with a mud volcano. We now know this view is incorrect. Slump clays and sandstones are present. Are these slump units the result of syndepositional or post-depositional movements? The first series of diagrams illustrates how these deformed units may have been formed between undeformed beds. Wack and Archie in 2006 proposed shelf edge collapse of a progradient shelf edge delta to explain the slumped units between undeformed beds. This is a drone video of the coastline towards Palmiste Point. We start with the recently refurbished Quinam beach facility at Car Park. The hillside on the left was terraced to minimize slope failure. Along the shoreline, a boulder apron has been laid to stop coastal erosion. However, it is clear from the trail of stones to the left of the facility that longshore drift is transporting and redistributed them. The beach has a fair amount of sargassum on it. Lines of stone in the sea and the beach represent remnants of sandstone beds that give clues to the strike of these beds. This first video ends at Palmiste Point. At stop 1, we are looking at lignitic claystones overlying a sandbed. Within this lignite, there are no discernible tree trunks or rooted zone. The sands are parallel laminated, and these dark black to grey laminae tend to be predominantly lignite fragments. At stop 2, we have channelized sandbeds with hematitic mudstone class channel land. The long axes of this class are aligned parallel to the bedding and can be used to infer transport direction. At stop 3, we have a striped parallel sand outcrop. It exhibits slumping and has large rounded blocks of lignite floating in it. These blocks suggest transport from a more proximal swamp source. At stop 4, we have alternating north-dipping sands and claystones. This is contrary to the regional south dip and is probably the result of post-depositional slumping. The hard sandstone is the result of near-surface meteoric and seawaters causing the precipitation of calcite cements. The claystones show some bioturbation. At stop 5, we have a headland of slumped sands underlain by slumped claystones and lignite blocks. The large rounded sandstone blocks are the result of differential erosion. At stop 6, we have striped parallel view of sands. The uppermost unit consists of slumped sands that are affected by numerous north-northeast to south-southwest fractures. At stop 7, this outcrop is in close proximity to the previous one and coincides with an oil seep identified in 1965. The outcrop is oil-stained, has a strong oil smell, and sands leave a light brown stain on your fingers. A close-up of the sand shows quartz grains stained by oil. The light color suggests a high API oil. No well drilled on the south dipping flank of the southern anticline has encountered oil. They are either dry or gas-bearing. At stop 8, we have near vertical claystones with thin hematitic mudstones. There are also some thin oil-stained sands present. At stop 9 is a large claystone outcrop with a left to right dipping fault. The inset illustrates fault gouge. At stop 10, we have the remnants of a Pleistocene terrace. Large sandstone boulders are being eroded from the reddish clays at the top of the cliff, forming this terrace. At stop 11, Palmiste Point, we are seeing almost vertical claystones. On the wavecut platform are exposed deformed slumped claystones and siltstone. Here we have a drone video of the wavecut platform at Palmiste Point. We have a drone photograph of the wave-cut platform at Palmiste Point, where deformed and undeformed clay stones are present. Finally, I would like to thank the dedicated geoscientists who made the time to attend this field trip.